holes punched in a card make us daytime astronomers. Confused? Let's do our experiment number 2 and see what a simple hole in a card can prove. A nice sunny day, and what we get is the shadow and bright circles of light. Some big, some small, just like the various holes punched in the card. Increase the distance further and further. Let the sun shine through. What we get are round circles, equal in size.
शायद सन की पूरी इमेज हो सकती है, क्योंकि सन तो बहुत दूर है और इधर से तो वो बहुत छोटा दिखता है, पर असल में वो बहुत ही बड़ा है। पर हाँ, पर सन की भी इमेज, वो पूरी सन की इमेज भी हो सकती है।
पूरे सन की इमेज, the whole sun? Maybe, maybe not. Let's move a step ahead and work towards improving the image. To make the dark room, you would need an old used carton, thick black chart paper, a white sheet of paper to act as the screen, a round plate, a cutter to cut the carton, some adhesive to stick things together, sticky tape, and a pair of scissors. Here's how to make it. Take the carton and mark its outline on the black paper. Cut it out. This has to be stuck inside the carton to block the light and keep it dark. Black sheets on 3 inner sides like this. Time to cut out the white paper. This will act like the screen. Black paper to keep it dark, white screen to get a nice clear image. Now, on the side opposite to the white side, mark a circle with the plate. This will be the window for light. Cut this out carefully. You may need adult supervision. What we have now is a box with 3 black inner sides, 1 white and 1 with a large round hole. Last but not the least, carefully seal all sides with the adhesive tape. This will make your dark room strong and also prevent any leakage of light. The portable dark room is ready. The same darkroom can be modified for pinhole imaging, and here's how. The round window for light has to be covered with a thick chart paper. Fold it neatly and stick with tape. The next step is to mark a little portion on the paper somewhere in the center like this and poke it. The idea is to make an opening for light. But this has to be neat. And for that, stick on this another sheet of paper with a neat hole punched in it. Here, the children have made a mold for the aperture. This is the pinhole. On one side, cut open a little window for looking inside. Observe how it's placed. The portable darkroom with the pinhole is ready. This set of children is determined to crack the secret of the pinhole. They have placed the box in such a way that the pinhole points to the sun, and the window allows them to peep in. What do they see? One sharp round circle of light. But what is it?
सन एक ब्राइट स्पॉट की तरह उस वाइट पेपर पे लग रहा था और सराउंडिंग अंदर का फुल ब्लैक था, इसीलिए हमें सन एकदम क्लियरली दिख रहा था।
नहीं, मुझे नहीं लगा था कि मैं सूरज कैसे देख पाऊंगी।
Suraj, sun, obtained through a pinhole, but not all are convinced.
आप बुद्धू पर आ रहे हैं ना, ये सूरज हो ही नहीं सकता।
When in doubt, seek proof. That is the attitude of a true scientist. So let's play with the dark room and see if the pinhole projects the image or is it just light passing through. Cover half a torch with colored gel and shine it through the pinhole. What do you see?
Even though the orange gel is on the lower side of the torch, I can see it on the top side of the image.
So what does that prove?
It proves that the image is inverted due to the pinhole camera.
How did you like the experiment?
It was very good. We had read about this pinhole camera in theory, but we actually understood it much better when we did this experiment.
When rays of light from the torch pass through the pinhole, this is what happens. We get an image of the torch bulb. The sun, a distant sphere. When we reflect its light through the pinhole, what we get is an image of the whole sun. We get the sun. A sunny day, some tall trees and daytime astronomers. The perfect combination to learn a new skill. Monkeys are great at climbing and they probably can estimate the differences in heights of trees. But if you asked them numbers, well, what if I asked you?
It will approximately be 40 to 50 meters.
40 to 50 meters. That's tall. But why guess when you can measure? No need to climb the tree or even look up. Some simple mathematics is all we need. The round discs of light under the tree are nothing but several images of the sun. Here's why. The spaces between the leaves act as pinholes. Sunlight falls through them and the images of the sun are created. The right time to measure is when the sun is right on top. Choose the biggest and clearest circle of light. A white paper sheet helps you to get a better image. Mark the circle. Time to measure. Time to calculate. The formula is simple. Diameter multiplied by 110. Why 110? Just take our word for now, but 110 it is. So the height of the tree. The diameter of the circle measured 10 centimeters. So that's 10 centimeters multiplied by 110. That's 11 meters. That's the power of daytime astronomy. That's the science of pinhole projection. Write your responses to us at Suraj Zameen Par, Vigyan Prasar, A50, Institutional Area, Sector 62, Noida 201309. You could even email us.